What's going on, physics students? What we're doing today is we're going to talk about Fermi problems, and we're talking about this dude named Enrico Fermi. He's an awesome physicist, probably one of my favorites. I am currently writing this curriculum as we speak, so I apologize if I haven't given it out to you yet. I actually just started writing it. I've got about 8 pages left, or done. I think that I've got about 15 pages to do. I can probably have it finished by the end of today. So I'll upload this, and then this will be from where you do your homework and basically where you learn your stuff. Okay? I'm not taking this straight from the textbook. I'm taking this straight from my mind. All right. Who was Enrico Fermi? This dude was an Italian physicist. He lived in the first half of the century, so the early 1900 to like 1950. Actually, I'm not exactly sure when he was born and died and whatnot, but I know that he was a brilliant dude. He played a significant role in the development of the first nuclear reactor, quantum field theory, nuclear physics, particle physics, statistical mechanics. Just awesome. He won the Nobel Prize in 1938. Obviously, I'm a big fan of Mr. Fermi. Now, what I think is really cool about Fermi is he came up with these kind of like, he was really well known for his ability to use logic and to kind of like approach things logically. He was like the Sherlock Holmes of the day. I imagine that if he applied himself to detective work instead of physics, we would be calling him Sherlock Holmes. Like, he seriously probably is that dude. Some of the advice I would give you today is we're going to be studying problems that might seem impossible. It might be very scary on how to do. In fact, I remember, Justin, earlier you emailed me and I asked you a question. You said, "Wait, we can do that?" And I think it was a question just like saying, "Well, if what is the circumference of the Earth?" Without looking it up, you know. And then you think, so, I mean, the way you would solve that problem, and I think that a lot of you did it right. I was grading a lot of your work. I think I graded everyone's work the other day, or yesterday. But the way you solve that one is pretty, I mean, you kind of got to remember, do you ever hear that song, Route 66? Now, I don't know if you're a big music fan, Justin. Do you ever get your kicks on Route 66? Have you heard that song before? I think it was made popular in a movie called Cars recently by Disney. All right. Yes, no, I need your response back. I need to make sure that, yeah, you've heard it before. Awesome. So Route 66, it says, goes from Joplin, Missouri Spring, and Bottville, San Bernardino. And then it says, and then there's a line in there that says, more than 3,000 miles all the way. So Route 66, 3,000 miles. Got it. Then it also says it goes from New York to LA. So just knowing that, I can actually guess the size of the circumference of the Earth. And I would say, all right, if it's 3,000 miles from New York to LA, you're crossing 3 time zones. You're crossing 3 time zones, so that would make one time zone worth 1,000 miles. If one time zone is worth 1,000 miles, I would say that there are 24 time zones on Earth, because that's how we divide up the Earth into 24 different time zones. So that means your Earth is about 24,000 miles. Exactly. Yes. So that's kind of what a Fermi question is. Now, I'm going to probably be asking you some seemingly impossible questions. And I'm not required for you to get like the most accurate answer. And I know that, Julia, you had a problem with like reporting too many significant figures. What I'm trying to get an idea from you is I need to develop inside of you courage. I need to develop inside of you no fear. Because I need you to get rid of the word "I don't know" from your vocabulary. And that's why I'm going through this exercise. That is why I'm going through the whole point of writing up my own curriculum, just to teach you this. And the way you do it is you do it one bite at a time. You just approach something, you approach it as small steps as possible. How do you eat a whale? You eat it with a fork and a knife and one bite at a time. Exactly. So, what I need you guys to do is just approach. You guys are going to be going into this thing, and it's going to be scary, I know, but just do it. And no respect has fear, for that is impossible. What humans can have is ignorance of fear. Ooh, philosophical. So, what is the materials we're going to need for this exercise? Well, we're going to need pencils, paper, and your brain. And I'll be honest with you, pencil and paper is optional. Brain is necessary. That's the only one that's like required. I used to stay up late with one of my friends, just kind of like hanging out, and we would talk about these things. All right. Let me start off our topic with talking about order of magnitude. Order of magnitude. Now, what I'm asking is, how much popcorn do you get per bag? You ever pop a popcorn bag? How much popcorn do you get? Now, when I ask that question, everyone always says, I don't know. And I say, dude, you're just so scared of answering. Well, is the answer 200? Is it 2,000? I just want to know whether, is it 10? Do you get, which one do you get? Do you think you get 2? Do you get 2? Do you get 20? Do you get 200? 2,000? 2 million? Which one do you think it's about? Which is it closest to? 2, 20, 200, 2,000, 2 million? Yes, I know it varies from brand to bag and all of that kind of stuff, but I would say generally 200. And you notice how Julia, even though Justin and Julia, you guys disagree whether or not it's the same, you know, like you guys are asking me, well, what brand is it? What bag is it? What is it that you're talking to me about? And I would say, okay, fine, you can freak out about those things, but you guys both said 200. Did you guys notice that? You guys didn't say 2,000. You didn't say 20. You both said 200. Now, it could be 900. It could be 200. But at least I know it's in the hundreds. So I would argue with you. I would venture to say that really the more important number in this answer, I would say the more important number in this answer is not the 2, but the zeros. But the fact that there are 2 zeros and not 3 zeros, or 4 zeros, or 5 zeros. So really, with Fermi questions, we almost don't care about the number in front. We care about how many zeros are trailing. Because I would say that that's a much more important number. Do you guys agree? Yes? No? You're ugly? Your breath stinks? What? Like, for example, which would you rather have, 20 bucks or $2,000? I'm giving you money, 20 bucks, $2,000. Come on, type it up. Come on, you guys should be excited about this. Yes, exactly. I would rather have $2,000 because of the number of zeros. Adding those 2 extra zeros actually makes a huge difference. What would you rather have me add? Would you rather have me add 2 to this number right here? Or 2 to the number of zeros I'm adding? I'd rather you add as many zeros as you want. In fact, if you want, you can take this number 2 down to 1 and still add a couple more zeros. I'd be happy. Right? So really, with order of magnitude, what I'm saying here, what I'm getting at here, is with these problems, we're only kind of worried about the order of magnitude. Yes, you'll come up with a number, and yes, that number might be interesting, but really what we want is is how many zeros there are. So on some of these questions, all I'm going to ask you is not what is the answer, but how many zeros are there. Does that make sense? In fact, order of magnitude is so important. I wrote it down. I literally wrote it down. Order of magnitude is so important that the only answer that you write down in the competition, and what I meant is I actually wrote this article so that I could prepare some students a while back for this competition that we were going to do on Fermi questions. But yeah. After we do what we're going to do is we're going to do a kind of a competition where we have order of magnitude, or where they basically do a competition on this. And I said, in the competition, the only thing that really matters is the number of significant, or not the number of significant figures you have, but the order of magnitude that you have. For example, in the competition that we were doing, if we had the number like 5.001 times 10 to the third power, all we would have to do is just say, all right, well, the answer's 3. Because all we were writing down is what is the exponent. After we record the number, we just record the exponent in there. Does that make sense to you? I realize that there might be a typo here. I don't know why I put 4 there. That should be 3. So anyway, and then I told you true story. And I wrote while I was writing this article, I said true story. When I was in an interview for a top research position, I was asked a series of difficult questions. One of the questions that stalled my rhythm was, how many barrels of oil is shipped into America each year? I told you that story last time, so I'm not really going to go deep into it right now, or again. But that was kind of what turned me on to these Fermi questions, and I thought that these would be really good to start making people think. That's what I'm going for here. What I'm trying to develop in you is I'm trying to develop the ability to think and the ability to have no fear. Just go in and do it. All right. What is the historical significance? Well, the story goes that the Enrico Fermi was this great physicist, and he took a napkin out of his he took, I think it was like index card or a piece of paper out of his pocket when they were exploding the atomic bomb in 1945. And he was kind of on one of those teams who developed one of the first atomic bombs. So he took out a piece of paper and he dropped it. As soon as the thing fell, and it landed like this, okay? It kind of went off at an angle like that, right? Because it fell down, but then the atomic bomb was right over here. Boom. And so the paper fell at an angle because it was blasted away. Now, obviously, he was in a safe enough distance so that he wouldn't be incinerated immediately. But we have bomb, and then it went off at an angle. And he says, based off that angle, and he kind of looked at it, and he stared at it for about 5 minutes, and he said, that was about a 20 kilotons of TNT blast. And then after that, they took another 3 weeks to do it. So he did it in about 3 minutes. They took 3 weeks to calculate it. It turns out it was 18.6 kilotons. Now, the fact of the matter is he still, even though he didn't get the exact number, he still got the right number of zeros. And that's the only thing that was really important. Does that make sense to you? So since he got the right number of zeros, you've heard of serial things. All right, fine. Since he got the right number of zeros, I think that that's accurate. That's accurate enough for me, at least for these back of the napkin calculations. Because oftentimes what I'll be doing is I'll be asking you guys to do these calculations. And yes, you can plug in every single number in your calculator and do. But if you can't be the kind of person to stand back and say, does that make sense to me? Is that a reasonable answer? Then I don't know if you would be a great scientist, you know what I mean? You guys should be able to kind of get a feel for this and say, that makes sense. The answer isn't 40,000, the answer is 400 or something like that. Does that make sense to you? Because one of the things I've noticed, and I'm just telling you what I've noticed, I asked you guys to do something like, convert, I think I asked you to convert the speed of light into miles per hour. And I asked you that one. And what you guys came up with was you guys told me something like, the answer is like 3 or 30 or something like that. And I'm like, really? The thing is going 300 million meters per second, And when you convert that to miles per hour, it's 30. Seriously? You made a mistake somewhere. You see what I mean? So that's why we were trying to go for those kinds of things. Anyway, let's move on, because I think these are really fun, and I keep talking about it, and I don't want to talk about the history of them. I want to actually do something, because I think they're awesome. All right, let's see. All right, let's try thinking about a few of these, okay? How many seconds are in a year? Now, let me give you a few pointers on doing these things. First, here's some good tips. Just deal with the exponents. That's all we really care about. The second tip is round off your values before you do the calculation, which makes it way quicker, way easier. Keep the units as a part of working the problems, because sometimes what you want to do is you want to keep the units to make sure that you guys need to do any conversions that you make. And the subjects that these can apply to, well, I'm introducing to you in the field of physics, but actually these are math problems. And they're not really even just math problems, they're logic problems. So you can apply them to chemistry, biology, geology, geography, economics, swimming, basketball, running, the census, food, waste generation, doctors, all of this kind of stuff. Does that make sense? All right. So, let's try this. How many seconds are in a year? We'll start off with that. All right? So, how would you do that? Well, I'll show you the exact way to do it. How many seconds are in the year? Well, I'll show you the exact way. Here's what it is. If you have 1 year, how many seconds do you have? Well, we can go 1 year is 365.25 days. Nope, oops. I want 1 year to be on bottom. And I'll put 365.25 on top. Days. Sorry, it's sloppy. Let me just clean it up a little bit. Hold on, sorry. I apologize. Alright. And then what we want to do is convert a day to an hour. So let's go down to hours. So 1 day, 24 hours. Alright. And then we want to go from hours to minutes. So 1 hour, 60 minutes. Then we want to go from 1 minute to 60 seconds. And we good. And the answer you get is 3155760. Cool? Should we even report that many sig figs? I'm just wondering. And if so, how many sig figs should we report? If that's not how many, then how many sig figs should we report? All right. Julia is saying, okay, you should report 1 sig fig. All right, let's talk about that first before we get into it. How many significant figures should we report? Well, first of all, let's not take into consideration the leap year. Let's just go 365. In this case, I would only report 3 sig figs. Now you ask yourself, why? Wait a second. 60 only has 1 sig fig. Right? This number only has 1 sig fig. This number has 2 sig figs. This number has 3 sig figs. This number has 1 sig fig. So why would I report my answer as having 3 significant figures in the end? Do you guys understand the question? what I'm asking is why would my answer be 3.15 times 10 to the 7th, I believe. Well, the reason being is because I would say that, no, all right, I think that all I see is J, so I don't know if that was Julia or Justin saying that. But yes, there are not exactly 365 days in a year, so therefore this 3 significant figures is counts. But I would say that these ones don't count. This one doesn't have just 2 sig figs. This one doesn't have just 1 sig fig. This one doesn't have just 1 sig fig. Would you like to know why? Yes, exactly, because they are exact conversions. That's exactly right. Because my question to you is, how many hours in a day? And you would say 24 hours. Is it about 24 hours? No. It's not 24 hours, almost 24 hours. Or how many minutes in an hour? 60 minutes in an hour. It's not about 60 minutes. It's exactly 60 minutes in an hour. Does that make sense to you? So these are exact conversions. So I don't worry about those number of significant figures. If you knew that it was exactly 20 hours, would it be like, yes, I guess technically you could write 24.000000000, whatever. But I guess those are some of those things. You should know those things. Those are the things you should like already know. That 60 seconds is defined as 1 minute. So I don't need to worry about any significant figures or any loss of significant figures because I can't get any more accurate than 60. It is technically right, 60.000000000, whatever. Does that make sense? So the only one that really contributes significant figures is this one. But we're actually getting off the topic of significant figure, not significant. We're getting off the topic of Fermi questions. Because the way you approach Fermi questions, you just kind of do this. All right. There is about 1 year. Okay. Here's how I would do a Fermi. Here's how I would do it Fermi style. This is the exact number, and I can only do that if I had a calculator. But here's the Fermi style. What I would do is I would go 1 year. All right, fine, 1 year, and that is 4 times 10 to the 2 hour. For if I want to convert year to days. I just rounded 365 into 400. Are we cool with that? Does that make sense to you? You understand why I did that? All right. Then I'm going to say, all right, then there's about 2.5 times 10 to the first power hours per 1 day. So what I did was I just 24 hours is, I'm going to round that off to 25. Sound good? All right. And then what I'm going to do is I'm going to say 60 minutes is, I'm just going to round that off to 40. I know I'm cheating. I'm cheating. I'll show you why I'm cheating. So that would be 4 times 10 to the 1 power, 4 times 10 to the 1 power. Let's go. All right. So, what is 4 times 4 times 4 times 2.5? Do you guys know? I don't know off the top of my head. What is 4 times 4 times 4 times 2.5? All right, let's do it this way. What is 4 times 2.5? That's 10, isn't it? Okay, so that's 10. Times 16 is 160. I'd say it's about 160. Got it? Times 10 to the what power? Well, how many powers do we have? We have 2 here, 1 here, 1 here, 1 here. So if I add those up, that would be 2, 3, 4, 5. Does that make sense? Did I just make sense to you? And actually, you know what? I'm looking at this, and I have no idea why I rounded it off to 40 minutes. I'll just put 6 over here. Because that's 60 minutes in an hour, 60 seconds in the thing. I don't know why I put a 40 there. So really what I should do is, this is actually 4 times 2.5 is 10, 36 times 6 is 36, so 36 times 10 is 360. So really my answer is 360 times 10 to the 5th power. Because I have times 10 to the 2nd power, 10 to the 1, 10 to the 1, 10 to the 1. If I add those up, that would be 2, 3, 4, 5. 5. We cool? You understand? If I were to convert that into significant figures, I get 3.6, or scientific notation, I get 3.6 times 10 to the 7th power. You understand what I did? Are we cool with what I did? You happy? But the cool thing about this is this. This is the thing that blows me away. I got this number without using a calculator. I just did it in my head. I got pretty close, actually. I'm a little bit higher than the correct answer. But the most important part is, look at this number right here. They're the same. Isn't that amazing? Isn't that like exciting almost? Yeah, I don't care, Miss Spaulding. So both of these have the same number of exponents, and I did that with just the back of the napkin calculations. Here, let's try another one. Ready? All right. I'm going to erase this. Take a picture of this if you need to. Ready? Hold down the command button. Press the 6. Press the button above 6, and then you'll be able to get that as a picture. All right, I'm going to erase. All right. For the average American woman, let's say Julia and Catherine. For Julia and Catherine, how many times is your heart going to beat in your lifetime? For Julia and Catherine, how many times is your heart going to beat? Well, you would say a lot. Now, please remember, I told you, don't give me those kinds of answers. Give me the don't just say, I don't know, plenty, uku plenty. No. What I want from you is, I want you guys to kind of think our way through it. All right, fine. Let's go Julia. Since Julia thinks it's just a lot, I'm going to say 1 Julia. Julia, how many years do you think you're going to live? See, I like that. I like that better. Instead of just saying a lot, what I want you to say is, I just want you to jump into it. Remember, how do we eat a whale? Well, we'll just jump into it. We'll just go. You say, okay, fine. There's about 90 beats per minute. All right. 3 minutes per year. What are you talking about, 3 minutes per year? There's a lot more than 3 minutes per year. Anyway, let's start off with 1 Julia. Julia, how many times do you think your heart is going to, or how many years do you think you're going to live? Let's say the average women live till the age of 80. You guys think that's accurate? In fact, all right, so 80. 80 would be a nice number, fine. How many, this is 80 years, so I want to convert years to minutes at least. Do you guys know how many minutes in a year? I'll tell you what, I can throw in a few things, but it's actually really easy. It's 525,600 minutes. Does that make sense? Do you guys see how I got 525,600? And if you don't, go and check out the play that's called Rent. And they sing a song in the movie called Rent, or the play called Rent. It's on Netflix. They sing a song that says 525,600 minutes, 525,000 moments, and yeah, and they're talking about how many minutes are in the year. So I just kind of memorized that number. But it's not because I'm a super genius. It's just because I like to sing in the shower. Anyway, there's 525,600 minutes, and I'm actually just going to round that off to 5 times 10 to the to the 5th power. Are we cool? Yeah. Justin's like, no, that song is in my head again. Fine, Justin, I put it in your head. Happy days. All right, and then somebody said that there's 90 beats per minute. So we got 1 minute, 90 beats. Shoot, all we got to do is multiply all these 3 numbers together and we'll get our answer. What is 8 times 5 times 9? We're just taking into account the numbers. What is 8 times 5 times 9? All right. What is 8 times 9? Tell it to me. I'm actually not that good at math. Isn't it 72? It's 72, right? What's 72 times 5? Well, let's see. If I did 72 times 10, that would be 720. Then I want to half that. So that would be 350, 360. Is it 360? You guys on calculators, what do you get? Because I got 360. 8 times 5 times 9. Just the numbers. 8 times 5 times 9. Just the coefficients we're talking about. Come on, talk to me, folks. I need you guys to talk back here. You guys have calculators. Just plug it in. 8 times 5 times 9. Anyway, all right, I'm going to move on. How many zeros do we have? Hey, I got the right answer. Awesome. How many zeros do we have? Well, I'm going to have 1 0 from here. I have 5 zeros from here, and I have 1 more 0 from here, so I'm going to say times 10 to the 7th power. And I would say that that is about correct. So my answer I would give is 7 beats. I would say Julia's heart will beat. If she lives to the healthy age of 80, her heart will beat about 90 beats per minute. Now, sometimes she'll be super relaxed, and that number will be 60. It won't be 90. Sometimes she'll be super hyper, and that number will be 100, not 90. But about 90 is about average, I suppose. That's what somebody told me. That's what you told me, actually. So that's what I'm going with. Now, I think when I solved this problem earlier, maybe I might have... What did I do? For some reason, I got times 10 to the 9th power. I almost feel like the answers that I'm coming up with inside of my paper that I'm writing here is not as accurate as the number of, you know what I mean, as my answer that I'm giving to you guys right now on the board. I don't understand where I messed up. Let me think about it. Are there really 525,600 minutes in a year? Let me look it up. Oh. There's 525,949 minutes. That is the wrong song. That song is not correct. So we're changing that song. 525,949 minutes. 525,949 moments in the year. Anyway. So I think that was right. 525 times 10 to the 5th. So that would be 5,259,949. That's 5 zeros. So 5 times 10 to the 9th power is correct. I think I just wrote it out wrong. Anyway, 525, I would say that this is my answer. Your heart is going to be, if you live to the average age of 80 years old, your heart is going to be 360. Oh, I get it. I understand where my problem is. Do you guys see it? Do you guys understand what I did wrong? I think Catherine's got it. I think Catherine was alluding to it. Do you understand why the book that I was writing says 9 and this answer says 7? I see it now. Do you see it? What is it? Yes, exactly. Julia, what I didn't do was I didn't convert this into scientific notation. If I converted that into scientific notation, these 2 extra places would count over there. So it would be 3.6 times 10 to the 9th power. And therefore, the Fermi's answer is 9. Because that's the exponent. Ah, I see why. Because I originally had 7, but it should be 9. And I was thinking, what's going on? But it's because I didn't convert this into scientific notation. Do you guys get it now? You understand what happened? I'm happy about this. I'm happy. I'm elated. It's time for me to end class because I'm so happy about it. Alright, so what is your homework over the weekend? Because we're not having class on Friday. In fact, next week, not this Friday, but the next week Friday, I want you guys to come in for an awesome lab that we're going to be running. But, what is your homework? Well, I'm going to start emailing your homework, but what I'm going to do is I'm going to give you problems that are like this. I think that what I'm going to do is I haven't finished writing it, but I'm going to give you problems like how many drops of water, how many inches of rain, how much gallons of water fell from Hurricane Isaias this past Friday on the Big Island. That would be my question. You know, just questions like that. How many gallons of water fell on the Big Island from Hurricane Isaias? You know those kinds of questions. And then you say, okay, well, you know, they reported it having this many inches of rain multiplied by the, you know, the area of Big Island. Now, Justin, I know what your style is. You're going to start giving me every single, Catherine, there is not a place in the textbook where we can review. Actually, if you want to go and read up on order of magnitude, that's where I'm kind of getting this from. But a lot of this is coming from my head, so I'm going to be posting for you guys the article that I'm writing right now as we talk. Got it? I'm going to be posting the article that I'm writing. That is what I'm using right now to teach you guys from, and it's exactly what I have. It's an article talking about how to do these kinds of problems. Does that sound good to you? So no, there's not a place in our textbook, but it's because Mr. Bove is currently writing the textbook as we speak. So I'll be posting that by the end of the day. I just got to finish writing the article. All right, Julia, are you on an airplane? Julia, are you in class on an airplane? Well, Julia's dad is a pilot, so it sounds like there's a lot of pilot sounds in the background, so I'm assuming that Julia might be. Alright, anyway, talk to you guys later. I gotta go. Okay, bye. Julia, come on in.